Hello guys, welcome to this particular session on this video. In this video, we're going to look at how you can actually automate from your data pre-processing to the training of your machine learning model. If you're interested in on learning how to actually do all these things, by the end of this video, you have a solid knowledge on how you can actually pre-process your data at the same time actually train your machine learning model all in once without losing any data on the way or without need for you to actually without the need for you to actually keep on doing each of them step by step. We can actually automate everything in a single step. So in this video, for this automation, we'll be introducing what's actually called that of the Scikit-Learn pipeline and that of the column transfer. From the name, the column transfer is the first step that when you want to process your data. This column transfer, you can actually maybe pick a particular model you want to actually use for your pre-processing of your data and a particular column that you want to actually pre-process, or you want to actually perform some other data's manipulation or data. You can say a column manipulation, maybe column dropping or column filtering, standardization, normalization, a whole lot of them. And for that of the column transfer, what the pipeline automatically does, it takes everything. When I mean it takes all of them and then do each of them step by step. So what this all basically these two guys does. The column transfer is for the working with the columns, make use of some models like that of the standard scalars, not label encoder, ordinal encoders, and then some other stuff that if you want to actually do. And then for that of the pipeline, it takes everything, both the every step that you took from that of the column transfer, and then it feeds into that of the pipeline to actually run the full automation. There are basically other stuff relating to this column transfer and this of the pipeline, but I just want us to keep it the simplest way possible as of now. So in this of our tutorial, I have the data that we're basically going to use, and the models that we're going to make use of is that of the standard scalar. We're going to make use of this of the standard scalar. We've actually learned how to make use of standard scalar in one of our previous video. We're going to make use of this ordinal encoder. We're also going to make use of this label encoder, and we're also going to make use of this one hot encoder. And the machine learning model that we're going to make use to train the model is this of the decision tree classifier. There are a whole lot of other. You can start to use the regressor. You can start to use that of the logistic regression, but this data that we are going to use is that of classification based data. So that is one of the reasons why I want us to make use of this of the decision tree classifier. So this is the data that we're basically going to, the first step is actually to have the data available. This is the data, the classification data. So when we look at this data, we'll have this of the educational level. This educational level will have the city, the department. When we look at this educational level, we'll also have the age, the salary, the year experience, and this is about target. So for this of the age, just looking at the ages from 21 to that of the 57 years of age, and the salary that each person will actually paid, and the years of experience, you can see they seem more like that of the linear type of they tend to be linearly, when you look at it, linearly in nature. And they will have this educational level, looking at the high school, the diploma, BSc, which is the BSc, MC, which is masters, PhD. I can look at other stuff. They will have the high school also. There are just a bunch of them. So we have this of the city. These are just some few cities I picked up from Nigeria. We have the Lagos, Abuja, Kano, Lagos, Port Harcourt, Kano. There are a whole lot of other just states that I pick up from Nigeria. I can say cities that is in Nigeria. So if in your case, if you want to use any other city, it's not a problem. And then we have that of the department, IT, HR, finance, IT, blah blah blah. There are a whole lot of them, and the gender, male, female. So when we look at this data, and then for this of the educational level, so which encoding are we supposed to actually make use of? When we look at this type of encoding, we know that for this educational level, the best type of encoding to actually make use of here is actually that of the ordinal encoding, because when we look at this, each this is more like a rank hierarchy type of data, because when we look at it, the the BSc and the high school certificate, let's think of it like the BSc and that of the MSc and the PhD. These guys are actually ranked. They are not actually, if you look at it, they are not actually more on that of the same level. So ordinary encoding is actually the best for this kind of problem. And we have that of the city. When we look at this city of a guy, if you remember that city does not really have any really much impact. When I mean the impact is not actually being ranked, or maybe the ranking state does not actually appear here, because the Lagos city does not have anything, maybe any rank, even though some states are being ranked, but it doesn't have any ranking to do with that of Abuja or that of the Kano. When we look at this of the department, the HR, the finance, or that thing, they don't really have any much thing. So for this of the city and department, I think the best encoding for us to actually make use of this is that of the one hot encoding, because there's not actually any ranking hierarchy that exists in these other ones. And then when we look at this gender, we know that definitely that is an ordinary encoding that we're basically going to use on this. And when we look at our target, because we already have male and female, it's going to be 0 and 1. So that actually makes sense, because ordinary encoding just more like that is do similar thing for that of the like what label encoding does. But label encoding are mainly used for the target, because they are 1D type of array. That is the output that actually the input they expect, and that's the output they actually give. So they are basically used on that of our Y variable, you can say, for our target. So and this our target, we are basically going to use that of the label encodings to actually handle this problem. So first of all, we need to actually we might want to actually make use of pandas to actually structure this of our data really well. Then we're going to pick our X and that of our Y. So we can basically do that. So the first step, let me just actually copy, so I don't need to actually start from the beginning again. So we're going to just copy this, that just basically the same thing, or we can just write it. So we can create a variable called df. So we are going to say, remember we imported our pandas as that of the PD earlier, so we can say our what PD dot what data frame. And this of data frame, I want to turn this of our classification, which is, I think that should be classification data. Yeah, this is our classification data right here. So I want to turn it into that of the pandas data frame. So if we've turned that, this is, if I've been following to this tutorial, I will know that when you turn it to a pandas data frame, it's going to be more that of the structured type of output that we'll be having. So we can get our X, how we have actually been doing. So our S is going to be this of the df. We're going to make use of that of the ilog to actually you can say the ilog to actually grab maybe all these columns from the, because we'll be dealing with all these columns here, which from age to that of the gender, so it's going to be that of the -1. So we can do this. We can say df dot what our ilog. So we're going to start from that of the what is it called, the, because this ilog take that of the row and column, so we want all the row, but the column we want to start from the starting and to that of the end, but neglecting of the last one. So for that of our y, for our y variable, so we can say our df dot what ilog. So I'm going to make it an ilog. If in your case you can actually decide to set the age here, take this age, create a new this and paste it there, but it all depends on your choice. So we can set our ilog. We want all the rows, and then the color, which color do you want is that of the last column that we actually want. So I think this is not hard to actually implement, but in case if you are still getting it confused, this is just basically what you did. We took this of the age, we took it and we pasted it here as the first step, and then the next was this of the salary that we have here. So let me just do it in case this is your first time. So this is the salary. The next was this of our years of experience. So years of experience. Do you need for this of the ilog in a station whereby your data is not quite really much? So we can do for that of educational level also. So we can take this educational level, paste it here, and then we'll have the city, the department, and that of the gender. So the space is here set in place. Like all what I did was just able to write for this of the x and the y column. Remember that this for this x, it takes that of the 2 dimension, so we can put another quote at the beginning and that of the end. So our x and our y lose go, but when you want to actually make use of column transfer and that of the pipeline, you can't actually make use of that of the label encoding, because label encoding actually uses that of the it takes one is actually made for that of the target, so it's not actually a good idea if you put it on your pipeline, because like I said, it's actually takes that of only 1 dimension. So for this of our target, remember that we are going to make use of that of the label encoding, and for that label encoding falls under that of the preprocessing on this of our Scikit-Learn. So I've actually had it imported earlier, like in our previous video, so I can say that of our the label encoder. So we're going to just fit it. So we're going to say the fit underscore what transform. We're going to transform this of this data that we have here. Simple as that. So remember, label encoding the fit. I just did everything in one. Like I can actually create a variable for this of the label encoder, and then you can use the variable to actually fit and then transform this of our data frame, which is df target, which is going to be this. So now this is going to actually turn our data frame, this of our target to zeros and ones. So, and the next step we want to actually do is to pick the columns that we want to actually use in that of the column transfer. So remember that for this educational, we want to use that of ordinal encoder. So we can say ordinal. Let's just give it a variable that makes sense. Ordinal. So we can say ordinal is going to be which column do we want to actually use for this of ordinal. So we want the educational level. We want to make use of the educational level. Remember, I already just pick the column, so not make use of that of data frame to pinpoint because if you put df here, which is data frame right here, they are talking about the data that exists within this of the column, so we should be careful with that. So the next we want to actually do is for that of the which column do we want to let's put this ordinal column. This is signified ordinal column. So for this of the city and department, like we say that the best encoding here is for 1 hot encoding, so we can say our 1 hot. You can say 1 hot cool, because these are the columns that we're basically going to use for the pre-processing. So the next is going to be this of our department. We want to actually make use of department. So if you don't know how to use this 1 hot encoding and this of the ordinal encoding, I made a tutorial on that, which is the videos before this video. So the next thing I want to make use of is this of our you can have the city also. So I want to actually let me put the city first before the. So let me put the city, Ctrl V, put this. I want the city and that of the department. And for this I also want to make use of this ordinal encoding for this of our gender also. So I'm just going to put it here. So for this of ordinal encoding, we are going to make use of this of the gender and for this of the educational level. And for the 1 hot encoding, we are going to use it on this of our city, and then we're going to use it on this of our department. I hope this is not hard to actually understand. So now we're going to let me get rid of this. So now we're going to implement that of the column transfer, because that column transfer is what we're going to use to pre-process this of the columns that were actually selected. So we can call it process. Remember, I can give it the name of virtual. So it's going to be this of our column transfer. Remember that this column transfer belongs to that of the I think that should be compose the compose sub module on that of the Scikit-Learn, which I actually imported here, which is its Scikit-Learn compose, and for this of the pipeline belong to that of the Scikit pipeline, as you can see here. So you need to import these two guys from Scikit-Learn pipeline, import pipeline from Scikit-Learn compose, import that of the column transfer. So this explains it really well. So for this of the we are going to have this of the column, which is going to be column transfer, and the way the column transfer takes its input is more on that of the list, because they're expecting to take much more argument on that. So it's going to put each particular section you want to actually do. You need to actually put in that of the tuple braces, and you have to actually give it a name. So first one I want to actually is going to be you can just call it or the encode, which is going to be for our ordinary encoding. And the next we want to actually use is that of the ordinary encoding that we have actually imported there, which is going to be our ordinary encoder, which is, remember that ordinary encoder is the part of that of the pre-processing. Like this was it, pre-processing. Yeah, this is it, ordinary encoder from that of the Scikit-Learn pre-processing. So the next we want to actually do is to actually give it the column that we want to actually it for it to actually pre-process. Now, in case we want this of the ordinary encoding, so we can actually paste it here. So this settles it for that of the ordinary encoding. So the next we want to actually do for that of the, okay, let's copy this, paste it here. So we want to actually do for that of the 1 hot. So we can say 1 hot ink, like I say 1 hot ink. So 1 hot ink, so it's going to have this the column that I want it to actually do. So here is going to be that 1 hot encoder, 1 hot encoder. So what we actually did here was the column transfer. We set the parameter we want. The first one is we gave it a name, ordinary, and just is the name we actually just wanted to set it. You can give it any name of your choice. So which encoder do you want to use? Ordinary encoder. And which columns do we want to actually encode? We want to actually encode this of ordinary column, which are this gender, and for this of educational level, like we saw earlier. So after that, the next we want to actually do is actually to send this information that we have here to that of the pipeline. So the pipeline now is now going to become our model. So we can set it to be model. So it's going to be that of the pipeline that we have here. The pipeline also takes the information more like that of the list, and also takes the pipeline and that of the ColumnTransformer also tend to do similar things. So the first is that of the process. So you can give it a name, process. So we want to do this. Remember that I said pipeline tend to do things step by step, meaning that I want it to pre-process the data first. The pre-processing that is going to do all these guys first. So it's going to be pre-process. So it's going to be this of our pre-process. Yeah, pre-process. After this of the pre-process, what next do we want to actually do? So when we look at our data, do we need to actually scale our data down? We need to actually scale the salary because it's quite much. So you can actually, some models might not be able to fit properly with it. So let's actually scale down our data a little bit. So we can say standard. I want to make use of standard scaler. So here is going to be our standard scaler, simple as that. Remember, everything needs to be inside the quote. So inside the quote, what is this? So it's going to do for that of pre-processing first, then it's going to standardize our data, to standardize this. So the next final step that it's going to do, I want you to actually use a machine learning model to actually fit on this of our data. So you can, since I want to make use of decision tree, I just give it a name tree. So you can call that of decision tree. This should be decision tree classifier. Simple as I can set other parameter that decision tree has. It makes that those of the mass depth, the mean sample leaves. You can set out the mass depth here, which is the mass depth. But I don't want to actually set it because we don't have any much data we have actually using for this of the training. So now everything looks really good. So the next we want to actually do is actually to fit this of our pipeline to our data. So we can say our model is now became our pipeline. So we can say underscore fit. So we can say, so this is going to be our X and our Y. It's now going to target this of the Y. It's now going to make use of the Y to actually for the encoding and for that of the pre-processing with the target of. So it's going to make use of the X as a features that is going to do for that of the all the encoding on, and then all the pre-processings on, and then Y is that of our target. So after this, we want to actually know the, okay, let me just copy so I don't need to start from beginning again. So this is actually it. Nope. Okay, so not that. Okay, before I don't want to actually fit this entire, rather than like we did the model of fit, but this is doing this is you don't have a problem, but most of the time it's always a good idea if you reserve some data for testing to know how well your model actually performs. So I'm going to make use of that of the train test split. So we actually talked about this in one of our videos, so I'm just going to copy that, just basically the same in case interested in actual learning. Remember that now the train test split, what is actually going to do is going to split our data. Just write your train S test, Y train Y test is going to be equal to that of the train test split. I explained this and we have used it so many times, so I don't need to actually keep on writing it again. After all, in the same file, so we are going to split our X and of our Y, and then the test size, the amount of data we want to actually reserve for testing. Let's assume that we have 100 rows of data. So it's going to reserve 20 rows, which is 20% of our data. That's 0.2 times 100 is going to be 20%. So it's going to reserve 20 rows of data, and then the model is going to use that of the 80% to actually train. So for the training, it's going to be now going to be our S train. So it's going to be our S train. What is wrong? This is going to be S train. For that of the Y is going to be for Y train. This contains that of the remaining 80% of the data. So that just basically the Y for the test is going to be remaining that of the 20%. So since we have actually done this, remember that our model is not that of the pipeline, which is going to refer to this of our model here. So, but for this of the column transfer and everything, it's not actually a must. It must actually end up have to be a model there that actually does for you. In case you want to do just for the preprocessing, but for pipeline actually just to do everything complete, to automate everything completely for you. So that would basically work pipeline. You can see that if I to do this manually, we have to actually ordinary encode step by step, create variable for ordinary encode that particular column want to actually do for that of the one hot column, and also we can also just do each of them step by step. But this with this column transfer and this of the pipeline, everything is done faster and simpler. It is easier to actually understand. There are nothing really actually confusing here. So we want to actually check how well our model does. So I'm just going to copy from this of our previous code, just basically the same thing. So I'm just going to copy this. So I'm basically just going to comment these guys. Then I'm going to actually here I want to predict our S test. Remember that the model have never seen this of our S test. So this underscore predict underscore probably I don't actually need this. So let me get rid of this. Not actually doing anything here. So what we actually did here, we make use of the model to actually predict our S test. So here, in case if you want to actually predict your custom data, you can actually, like we have seen earlier, you can actually, maybe your data you want to actually predict is maybe in a data frame or in a CSV file, you can actually put it here. But if it's not that, in case if we just a single data that maybe single data you want to actually predict, you can actually this 1 2 3 4 5 6 7 there are 7 columns here. So definitely your data have to have that 7 can say 7 can say elements of data on this. So let's assume we want to predict custom data for the age. Let's assume for 2 is set to here. Maybe want to actually for, or is this going sideways? So maybe for that of the salary, years of experience and educational level, maybe want to actually for years of experience, maybe 34 educational level. Definitely everything is going to be turned to that of the number. So you can set 2, and for you can just set for other one is up to I think that should be 8. So here is 1 2 3 4, you can say 5 6 7 on that of the 8. Just random data. It's going to when you print your Y predict, it's going to give you what the model actually predicted for that all the features data that you actually sent it in. So in case if it was stored in a data of a data frame, you can actually just put the data frame directly. Remember that since the data frame doesn't have that target, you can just file it in here directly. So we're still going to see how you can actually do that. So let's actually see for that of our S test. for S test, I just want to predict, because S test is that of the features that was being reserved, features with data that is being reserved for that of the testing purpose. So we are going to see the accuracy, how well the model performed on that of our can say our Y test and against that of what was actually being predicted. So it's going to be how well did it perform on the new data that it have never seen. So this is actually a good idea for that of the testing purpose. So in case if you want to deploy a model for global use, you must actually have to use this train test to see how your model perform on the new data. Then after that, you can actually train it on the full the complete data. So let's actually run this and see what we have actually been having all this while. Then we are going to learn how to actually do for that of the custom data. Like I explained how, if you want to actually predict your own, you can just set here is where you are going to set the data you want to actually predict. So everything, remember that I said that for this of the pre-processing and for this of the column transfer and for the pipeline. Column transfer is to handle that of the column, and for the pipeline is actually to automate every other thing. We get this type of error. What is this? Let's actually scroll up. Let's go up. Why do I have this type of error? What is this error? Okay, found unknown category high school in :0 during transform. Okay, let's actually go up a little bit. This my produce. I'm beginning to have idea of the error that I have here. Okay, so the problem that I'm seeing here is basically like when we actually did for that of the, when it was trying to fit the model, when we actually did for that of the split and that of for that this train test split, we actually split it for that of our X and for that of our Y. I remember that our S and Y was this guy that we actually, let me just bring both of them include. So it was actually these two guys, and when we come to this of our X was actually we set the columns automatically, so we don't have any issue for this point. So the problem that we're having now is we fitted our model on that of the S train and that of the Y train. So doing that of the encoding, remember that the model is now going to take this S train and this of our Y train. The model is going to actually take it and then do the pre-processing on it. So during that of the testing, because what this split is just to split our data for testing and for training. So that when we look at this, I will have this error down here that we got something like high school. When we look at this high school belongs to this of the educational level, even though we set it for this of ordinary encoder. This high school, when we look at this high school, this was the first thing. So from what actually happens here is that when it's splitted for the training and for that of the testing, this high school never appeared in that of the training. So the model doesn't know or how to actually encode this data. Hope this is not hard to actually understand. The model does not. Maybe some like diploma might appear on that of the for the when it was being training. The BSc might appear, the MC might appear. They won't be surprised that maybe the PhD and the high school didn't appear when it was on that of the training. So the model only sees the ones that appear on the training. So during when you want to actually make the prediction, then this high school that didn't appear on that of the training because it wasn't being processed on. Now you want to actually predict on a set of data that have high school that it was not being encoded on. So you can see this is actually one of some things you might actually mean. That's why most of the times for the fitting is most of the time is being fitted that of the complete X and the Y, not actually on that of the train test. But using that of the train test is the best case, because what this actually does for you to actually reserve some data for you can actually use for that of the training purpose. So I think the best way to actually handle for this of the one hot encoder, the best way to actually handle is actually set what is actually called handle unknown. So we can actually set that of the, I think that should handle unknown for one hot encoder is basically simple. You can actually set it that of the ignore, simple as that. Ignore, set it as ignore, so it's going to ignore that. And for this of the ordinary encoder, it also has that of the, I think that should be handle unknown also. Out of the handling of the unknown, there's also something called use encoded value. So this use encoded value is actually the best. So use the encoded value. You want to also set for that of the unknown values. What do you want to actually set it? Most of the time, you can use for models like this of the tree-based model. You can actually set it to that of the -1. But when it comes to that of the something like linear models and maybe like SVM, which is support vector machines, which are for maybe make use of distance, setting some value can actually trigger some, maybe you can actually trigger it to find some patterns on it. But since we're using tree base, which is this strong tree classifier, so we can actually set our unknown value is going to be unknown value. We can actually set it to be -1. So those of the unknown value is going to be handled. It's going to set it to that of the -1. So this is one of the problems that I can see that this is actually facing, because it's going to take that of the S train for the training, and then it's going to be processed on it. The ones that didn't appear on that, or some elements like this high school, as you can see here, it didn't appear on that of the training, it appeared on that of the testing. So the encoding was not actually being done on this. So the model doesn't know how to actually encode it, because it didn't appear in its own side when it's doing the distance. So, but if we actually feed it our full x and y here, maybe we set our x and y, we're not going to have any problem. Everything is going to feed. But this train test split actually splitted this. So that's where some actually appeared here, some didn't actually appear in some particular places. So that's basically what I see that actually happened there. So let's actually run this to see whether if this resolve our problem. Remember that you can that of the unknown to handle that of the unknown that appear not of the our S test. So I'll say we set for that of the one hot encode, we set it to handle ignore. I remember one thing you should know, that our data we're dealing with is a small amount of data. This will be how many rows? When we look at this, we're having only 15 rows of data, which is not actually ideal for any machine learning model. So when we look at this, let's actually go up. I will have the accuracy was actually that of the 66%. This was actually the predicted. When we look at this, we will see that the output was actually only just 3 things that actually is predicted, which is actually like the test data only contain 3 rows of data. That you can see the confusion matrix. This is actually for the true negative, and that of the true positive, actually that of the false and positive. That means you can see true negative, true positive, he was able to predict 2 correctly, and that he predicted this guy positive. Meanwhile, it was actually that of the negative, so it's actually false positive. So you can see this is actually making sense. That is as if he predicted 2 out of the 3 correctly. So we have precision is area defined and being set to 0, label with no predicted sample. Use 0 division parameter to control the behavior. Blah 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 blah. So when we look at our precision, 0.67, weighted average. When we look at our this is our F1 score, 0.8, and our recall here was 1 actually. So the model didn't actually learn any much pattern here, because from the look of it, number one thing is that when we look at this, our data is not actually, this is actually just 15 rows of data. So it's not enough for any machine learning model out there to learn. It's not enough for production. So still talking about production, let's say you want to actually save your model for somebody else, maybe a friend of yours can actually make use of the model to maybe, let's say after you're done training a model, you maybe want to sell it to companies, to maybe the company want to actually make use of that your model to actually make predictions. So they don't have the resources to actually train that model again. Maybe you have data after you're done training, and you want to actually save this model that we actually trained. So how can you do that? How can you save the model? Because first of all, you need to actually save the model before you can actually give it out. So how can you save the model? To save the model is basically simple, and this is one of the things we'll be talking about in our next video. So if you feel interested in learning how you can actually save your model, make sure to watch the next video, which I'll be explaining the simplest or the 2 best way to actually save our model by making use of the 2 simplest and the 2 most universal used way to actually save our models. So I think we have concluded it for this video. If you find this video anywhere useful, don't forget to hit the subscribe button. So if you are interested in the recap, this is actually what we actually did initially. I talked about that of the what is actually this of the ColumnTransformer and this of the pipeline. Like I said, they belong to that of the pipeline, belong to that of the pipeline sub module, and the column transfer belong to that of the compose sub module on that of the Scikit-Learn. So pipeline is to automate the process. Column transfer is to handle that of the column. So this is natural transformer, not transfer, to handle that of the column. Remember that what we actually did here was one of the basic. That there are still a whole lot of complex way you can actually use to make use of this column transfer. Remember that the way it takes the input is more like that of the list, so you can actually set more and more and more and more. Remember what we did here. For this or the pipeline, the process is going to be done first. So this rule is going to happen first after the encoding of this of the educational level and that of the gender, because that's what I actually said here. The colon is going to be ordinary colon, so which is going to be for this of these guys, and for the one hot encoding is for this of the other guys. It's going to be done first. It's going to handle for the encoding and for that of the ordinary encoding and for that of the one hot encoding. After that, the entire data is going to be standard scaled. It's going to be scaled down. Then after that, we apply that of decision tree classifier on it that I predict the model. So and then we're able to solve the problem. Remember this when we had the problem, so we don't have choice but to handle it the unknown. For one hot encoding, we set that of the ignore, and then for ordinary we set it to that of use encoded value and setting the unknown to be that of the -1, and then that actually was able to solve our problem. So remember that I explained the problem was that when it was encoding, it only found that of the training. So but on that of our testing, it never existed. So some features, there are some data points that never existed. So maybe it wasn't being encoded properly. So after we were able to solve that, we got our model to be able to at least reach to the accuracy of 66.6%. I think that is not enough, but we didn't actually tune any particular parameter. We didn't actually add any other parameter that this or the decision tree actually takes. So I think with this is actually what we actually talked about in this video. Other things, train split, it has a special video. This accuracy score and confusion matrix also have its own special video. So if you feel interested, make sure to actually check it out. So I'll be happy to see you in the next video. Thank you for watching.